Good morning, everyone. So today we are going to see the load curve and the different, what is the load duration curve and the difference between those load curve and load duration curve, and also the numericals on this load curve. Okay, this particular point is very important whenever we considering to study the economical analysis or carry out the economical analysis of the power plant. Okay. So first, that is load curve. We saw the basics of the load curve. So the basically the load curve means it is it is the consumption of the electricity, or we can say the demand from the customer with respect to time. Okay, if you plot the demand of a customer with respect to time on x and y curve, we are considering the x-axis as a time and y-axis as a demand. So when we plot that one, it is called as a load curve. Now, a load curve we can draw for one day, for the 1 month, for 1 week. It is totally depends on you. Generally, whenever we considering the power plant, working of the power plant, the load curve, monthly load curve has been used, or we can refer, or also the seasonal load curve, or we can say the yearly load curve. Okay, means what? These changes or the types of the load curves will be depends upon the time period which we have considering. Okay, now the fundamental difficulty with balancing the supply from the particular power plant and the demand from the customer, it is derived from the physical nature of the electricity. Okay, means what? We cannot store the electricity. So whenever there is a demand, we have to produce the electricity, right? So in that case, as we cannot store the electricity with the sufficient manner, or we can say with the efficient manner, in that case we have to produce, or we have to generate that much of electricity which is required for the customer, which will be directly used by the customer. Now in that case, this variation in the demand, it is depends upon the time. It is depends upon many other factor, like the requirement of the customer. Okay, or the which type of consumer it is, the type of the customer, it is also important. So the demand for the electricity is changing. It is changing with respect to time. It is changed with respect to customer, and it is changed with respect to the consumer which is used that electricity to which applications. Okay, so for to analyze or to find out the exact demand at the particular time, we have to draw the load curve. Now this load curve we can draw by using the previous data, or by using this load curve we can generate the electricity, or we can plan to generate the electricity. Because first of all, whenever we install the plant, any power plant, and if we going to start to generate the electricity, or start to generate the power, we must know what is the requirement by the consumer. Okay, what amount of power the consumer want or the customer want. So for that, the drawing of the load curve or the analysis based upon the load curve is very important, and for that you will require the load curve. Now the basics of load curve, as I mentioned, it is just a graph or graphical representation of the demand with respect to time. Now, in this regard, electricity is a unique commodity and it is mostly used in many applications. Now, the rate of its production must be balanced with the rate of which is that rate of consumption, right? Because we cannot store the electricity. So, in that case, we can use the load curve. Now, the reasons for the variation, there are many different reasons for the variation that we saw in the last lecture also. That is, the daily variation is there. This is because of the change in the connected load. Okay, the different time of the day reflects the pattern of working hours and etc. So based upon that working hours, based upon the many factors like the lighting, cooking, heating, etc., the daily variation will occur. Similarly, weekly variation is also there, because on the weekends, the whatever the electricity consumed by the particularly different industries or different enterprises are very less. In that case, whatever the energy consumed by the domestic residential buildings are also less. So it is because of that, during the weekend days, the consumption of the electricity will be less, and that is the variation caused because of the different factors. Okay, So that is the weekly variation. Then the seasonal variation. Seasonal variation means what if in the whole year, what will be the variation with respect to season? Because in the winter, the electricity consumption has been increased. In summer also, electricity or electrical, or we can say the power consumption is also going to be increases. So that is the seasonal variation. Then random variation is there because of the any other reason. If the demand of the power will increases or decreases, that is called as a random variation. It may be because of the system failure. It may be because of the grid failure. Sometimes it is because of the sudden weather change, etc. So whatever be the reason for the random variation, and then next will be the long term growth. Now, the long-term growth means what? In previous 10 years or back in the 2011, the electricity consumption by the one particular person in India is very less whenever we compare it to the today's electrical consumption, right? Or the power consumption. So, why it is increased? Because of the economical development, and that is because of the growth, economical growth. So, the electricity consumption or the power consumption per capita has been increases. Okay, it is because of the many other factors like the economical factor or any social factor is there, then technology advances are there. So because of that, the consumption of the electricity per capita has been increases. So these are the reasons because of which the demand is always going to be vary with respect to time. So whenever there is a variation in the demand, we have to also vary, or we have to also reduces or increase the particular power production. So for that we require to draw a load curve. So you will get the idea at that particular point of the day what should be the electricity generated or the power generation should be there. Okay, so that idea we will get in the particularly or by using the this particular load curve. Okay, now load curve, it is again it will be vary with according to the customer type. What will be the type of the consumer? It may be a residential building, it may be a commercial building, or it may be industrial building. So it is depends upon the customer. Also, it is depends upon the temperature and holiday seasons. Or those are the different factors which are affecting on the variation. Now, there are two types of the load curve, or generally we call it as a load curve and load duration curve. Now, there is a slight difference between load curve and load duration curve. Okay, simply load curve means it is just a presentation of the electricity demand at that particular point with respect to time. Okay, so if you consider there is a demand, or we can say the demand on the y-axis, and x-axis there is the time. So this particular load curve indicates means what? It will indicate that that particular curve, which will indicate the power consumption at that particular time. Okay, so here from 12 a.m. to again 12 a.m. or 0 hours to 24 hours you can write down, and this curve will indicate the variation of the demand from the consumer with respect to the 24 hours or in the particular one day. Okay, you can also draw this for the 1 month, you can also draw this for any time period. Generally we are used that year to year variation, so you will get the idea how the demand has been vary with respect to the season, with respect to the time, okay, or with respect to the month. So this is called as a simple load curve, and it is over the time. So it will be shows the amount of electricity required by the customer over a period of time. Generation companies use this information to plan how much power they will need to generate at a given time. Means at this particular point, consider at 6 a.m. Okay, at 6 a.m. at morning, we require this much of electricity. Okay, or the customer demands this much of electricity. So the generation companies will know at that particular time the customer required more energy. So in that case, in that particular point of time, it will generate the more electricity. Okay, so that's how this load curve has been useful to particularly plan the generation of the electricity. Now, second point is the load duration curve. Now, it is very similar to the load curve, but in this load duration curve, what we are going to do, we are going to plot this demand. Okay, we are going to plot this demand from from decreasing order, from highest to the minimum. Okay, so how to draw this particular load duration curve that we are going to see, because there are many numericals will be based upon load curve and load duration curve will be there. Okay, so it is similar to the load curve. The information is the same, but the presented in the different form. The whatever the information in load curve and load duration curve is the same. Okay, just it is presented in the different form in load duration curve. These curves are very useful for the selection of the generator. Now this load duration curve is used to selection of the generator. Okay, means what type of turbine or what type of generator we have to select in that for that particular power production. That has been depends upon load duration curve. What should be the capacity of the generator? It is depends upon load duration curve, because in the load duration curve we will get the what is the maximum demand of the customer, and for what time it will require the maximum demand. Okay, means it is gives you the reference to select the capacity of the generator. Okay, because that is the maximum energy should be generated by that particular generator, right? What is the demand from the customer? So it is taken from the load duration curve. Okay, so this is the load curve. Typically, it is a type of load curve. Okay, first one is the daily load curve. Second one is the yearly load curve. You can see here. Okay, so as we can see the daily load curve at the midnight, we required the less energy. Okay, as we move towards the energy consumption has been decreased during the night time. Whenever at the morning time, it has been start increasing from nearly from 6 a.m. to the 12 a.m. So you can see there is a sharp increment in the requirement or the demand of the electricity. During the daytime, it is again required very high amount of energy. This is generally for the commercial building, or we can say the industry type of buildings or that particular industry customer. Now you will see there is a sharp increment in the requirement of the electricity, and then whenever at the night or the evening time it will be reduced. So this is one type of just one type of load curve. Okay, this load curve is again going to depends upon the what is the customer type. Okay, what is the requirement of the customer? It is also going to change with respect to time period. Here we are considering the day. That's why this type of load curve is there. Okay, generally this type of load curve is for the commercial buildings. If you considering the residential building, this load curve will be the different. Okay, now from this load curve, we can also calculate the average load. What should be the average load we have to generate during whole day, and that is the value of average load. Similarly, you can draw the load curve, yearly load curve. Okay, means in this case, the time period is 1 year. We are considering 1 year time period, and for that time period, we are going to draw the load curve. So you can see during the winter season, the increment we are required maximum the electricity consumed by the consumer. Then as summer comes, the reduction in the energy requirement, you can observe the reduction in the energy requirement. It will be the minimum during the rainy seasons, and it will again going to be increases as the winter is going to be increases. So typically this is for western countries. You can draw the load like this one. This curve is will be different for the each and every location. Okay, it is depends also on the weather how much electricity is required. Now it is also going to be changed with respect to the customer. So there are many other factors which are going to affect whenever we draw one particular load curve. But it is important, because whenever what type or how much electricity it should be required, that we got the idea from this particular load curve. So during the January we required maximum demand, it is having maximum demand. So the generating company with those use these particular values, or those use this particular data to produce that particular or plan to produce the particular power. Similarly, you can also draw the load duration curve. It is simply just we rearrange the terms from the in the descending order of the magnitude of requirement or the magnitude of the demand. Okay, so it is also similar to the load duration curve, but this load duration curve is mostly used to selection of the generator. Which type of generator we have to use or we have to select in power plant, that is depends upon the load duration curve, because it will give you the maximum requirement or the maximum demand of the customer, and it is also shows you the duration for which it is required that much of maximum demand. Okay, so this is one one particular example. You can see on the left hand side, this is called as the load curve. On the right hand side, this is called as the load duration curve. Okay, so left hand side, you can see we just plot the requirement, actual demand of the customer with respect to the time. So you can see this is the load curve. So during first 4 hours in the night, we require minimum demand. Then from 4 to the 8, the demand will be increases. Okay, it will increases up to the 15 megawatts. Again from 8 to the 16 or 8 a.m. to the 4 p.m. It is again going to be increases. It will be the maximum 20 megawatts. And after the 4 p.m. it is going to be decreases. Okay, and from 4 p.m. to the again 12 at night, you can see there is a reduction or the demand will be the less or minimum demand is for the electricity. So this curve is known as the simple load curve or day load curve, or we can say the daily load curve. Now we can going to rearrange this particular day, load curve into the load duration curve. Now this particular load curve is used to find out how much energy is required at the specified time. Means if you want to, if any generator company want to know how much electricity it should be generate at the 12 noon. Okay, at the afternoon. So it will going to simply just see this particular load curve, and he will get the idea around how much or approximately how much in electricity it should be generated. So it will generate 20 megawatts at the 12 p.m. Similarly, at any point of time, how much electricity should be generated, it will be shown by the load curve. Now, the difference between load curve and load duration curve you can see here. Okay, so you can see here the maximum demand is the 20 megawatt, and this 20 megawatt demand is for nearly 8 hours. Okay, it is for 8 hours, right? So the load duration curve means what? It is simply rearrangement of the particular load curve with load setup in the descending order of magnitude. So we only going to set up these loads in the descending amount or the descending magnitude. Okay. And in that case, during plotting that particular loads, we have to consider time also. Means for how much time it will require this much of electricity or this much of power. So maximum load or the maximum demand is 20 megawatt. Then second step you can see that is the 15 megawatts, and third is the minimum load, that is the 5 megawatt. Now first of all, we are going to start from highest to the we are going to go for from the highest to the lowest one. So we are first considering highest load demand or the maximum demand. So first one, that is maximum demand, is the 20 megawatt, and it is for 8 hours. So in load duration curve also, on the x-axis we are taking time, it is in the hours, and on the y-axis we are taking the similar load in megawatts. So first of all, we require 20 megawatts for 8 hours. So we are going to drawing 20 megawatts for the 8 hours. So for first 8 hours required 20 megawatts. Okay, so this will be our first load or the maximum load required. Okay, next load we have to consider. Now next load is the 15 megawatts. This one you can see, next step is the 15 megawatts, and we required 15 megawatts for nearly from 4 a.m. to 4 p.m. Okay, now you will see it is only for 4 to 8. But if you saw the total width of this particular diagram is, whenever we required the 15 megawatts, it is from 4 a.m. to 4 p.m. Means nearly for 12 hours we required the 15 megawatts of electricity. So that's why we have to draw for first 12 hours up to this one, we have to require 15 megawatts. Now generally what is happen, whenever we producing the 20 megawatts for the first 8 hours, means what, we are producing more than the 15 megawatts. Means whatever this first 8 hours, it is came under the 20 megawatts load curve, and next one will, next 4 will be remaining, that you can draw here. Okay, so up to 12 megawatts or up to 12 hours, you will require the 15 megawatts. That is the second one. Now, third step, that is the 5 megawatt. Okay, third load, we or the magnitude of the load. So in that case, you will see we require 5 megawatt for 24 hours. Means for 24 hours of the day, we require 5 megawatts. Minimum, we require 5 megawatts. So we can also going to be draw similarly here 5 megawatts. Okay, for all 24 hours. Okay, so what we do, we just done that. We are going to we are just rearrange these particular loads in the descending order. First 20 megawatts, then 15 megawatt, and then 5 megawatt. Similarly, in different types of the numericals, you have to first of all draw the load curve, and after that you are going to draw the load duration curve. That is the basic one. So if you saw here the load duration curve, if you saw, I will just highlight that one. So this is the main load duration curve. Okay, you can, if you draw the outline for this one, you can see this one is the load duration curve. Okay, this is the load duration curve, and the area below this load duration curve, it is gives you the total energy consumed or total units of energy consumed by the customer. This area and area under the load curve, it is the same. Okay, it is exactly the same. Okay, there will be no any change in area under the curve, and these both areas will shows you, or it will indicate the total amount of energy consumed by the customer. Okay, so that is the load curve and load duration curve. So that is the difference between load curve and load duration curve. There are many examples. Examples will be there, or numericals will be there in exam. Based upon, you have based upon this load curve and load duration curve, we have to draw the load curve, or we have, and based upon the load curve, you have to draw the load duration curve. Okay, so those examples we are going to see now. So this is one of the examples in which we have the power consumption by the customer has been given for the entire 24 hours. Okay. Now in this, we have to first of all draw the load curve, then find out the load factor of the power plant, and what is the load factor of the standby equipment of 20 megawatt capacity if it takes up all the loads above 60 megawatts. Okay. So first of all, based upon this particular information, we are going to draw the load curve. Okay. In many numericals, they will also ask you to draw the load duration curve. So based upon load curve, you can draw the load duration curve. So first of all, draw the load curve. Okay, simple load curve. So just taking the, on the y-axis, there is the magnitude of the load. Okay, and on the x-axis there is a time in hours. Now total time is up to 24 hours, so 0 to 24 hours, these are the timeline. And on the load curve, you can see the maximum load is, we get it 80 megawatt. So we are just taking up to 90 megawatt on the y-axis. Now simply draw the load curve. So you will see for 0 to 6 hours, for first 6 hours, the load in megawatt is 20 megawatt. So you will going to draw the vertical line 20 megawatts up to the load 6 6 hours for first 6 hours. Okay. Now second 6 to 10 hours. Okay, from 6 to 10 hours, the load has been increased from 20 to 50 megawatts. So here sudden increment in the load has been taken place, and it is increased from 20 to 50 megawatts, and it will remain 20 to 50 megawatts for next 4 hours. So up to, if you saw, up to 10 p.m. or 10 hours, it will remain the 50 megawatts. After that, next 2 hours, 10 to 20, 10 to 20, 12 hours, the requirement or the demand will be increases from 50 to 60. So again, sharp increment in the demand, and it will be increases from 50 to 60. Now next 4 hours, from 12 to 16 hours, the demand will be reduced or decreases from 60 to 40. So again, you can draw, or you can reduces the power demand from 60 to 40, and it will remain up to that 16, 12 to 16 hours. So these are the time steps you can see here. Now again, from 16 to 20, it is directly increases from 40 to 80. So it will again just doubled this one, and we will achieve the maximum demand during that particular time period. So 16 to 20 for this particular 4 hours, we require 80 megawatt of electricity. That consumer required 80 megawatt of electricity. Then again 20 to 12, it will be reduced to the 70 megawatt, and from last 2 hours it will reduce to nearly 40 megawatt. So this is the simple load curve. If I will just highlight this particular load curve, so you will understand this one is the load curve, total load curve if you saw. Okay. Now, based upon this load curve, you can also draw the load duration curve. Okay, you can also easily draw the load duration curve. I will just show you how to draw the load duration curve. So similar to load curve, we are taking x-axis, x-axis and y-axis. Okay, on y-axis, demand will be there. That will be in megawatts. So similar load we can draw here up to 90 megawatt. Okay, it is the 80 megawatt like this one. Okay, so up from 0 megawatt to 90 megawatt. In the on the x-axis there will be a time. This time will be again 24 hours. So it will be up to 24 hours, 0 to 24 hours. You can write down here. Now, as we know in load duration curve, first step is to find out the maximum demand. So maximum demand is this during the this particularly 16 to 20 hours, that is the 80 megawatt, and it is for 4 hours. So we can going to write down or just draw the first of all maximum demand for the 4 hours. So if you saw here, it is the maximum demand 80 megawatt for the 0 to 4 hours. Okay, next the next one, or the less than the 80, what will be the maximum value? Next again, that is the 70. Okay, now as we know in the load duration curve, we are going to rearrange this load with in descending order. Okay, so highest load or highest demand will be the first one. Then we are going to plot the lowest demand. Okay, so from highest to lowest, we are going to plot here. So you can see there is a 70 megawatt of load requirement. This is during the only for from 20 to 22 hours, means only for 2 hours we required 70 megawatt. So from here, if you consider this one is the 70 megawatt, it is required for 2 hours only. So this will be the for 2 hours 70 megawatt will be there. So 4 to 6, that will be the for 2 hours we require 70 megawatt. Then next maximum demand is the 60 hours. 60 hours again it is required for 2 hours. Sorry, 60 megawatt is again required for 2 hours. So again here on the 60 megawatt scale, we are going to take a 2 hours duration. Okay, so it will require 2 hour duration. It is called as a 6 to 8. Okay, now next one is the 50 megawatts of electricity required for 4 hours, because 6 to 10 it will require 50 megawatts. So again for 50 megawatt it is required for 4 hours. So we can write down here. Now 8 plus 4, 12 hours. Okay, so this is for up to 12 hours. Again next, after 50, next demand is the 40. Now here you can see for 40 megawatts there are two different time range for which we required 40 megawatts. First 12 to 16 hours we required 40 megawatts, and also from 22 to 24 we required the 40 megawatts. So for these 4 hours and for these 1 hour, 2 hours, we require 40 megawatts. So if you add these two time periods, we will get totally for 6 hours we require 40 megawatts. So for the whenever we considering the 40 megawatt, just considering this one is the 40 megawatt, and it will require for nearly 6 hours. So if we draw, this is for 6 hours. So 12 plus 6 again 18 here. Okay, this is 40 megawatt of electricity required for the particular one. Now just focus on this one, because here in two different time ranges we required 40 megawatt. That's why we have to add these two one in load duration curve. Okay, in load curve we can draw with respect to time whatever given in this particular chart, but in load duration curve we are going from highest value to the lowest one. So that's why we have to add up these two one. Okay, and last one, that is the 20 megawatts again for 6 hours. So Again here 20 megawatt for the remaining 6 hours. Okay, so this is called as a load duration curve. I will just highlight the outline of this particular load duration curve so you can understand. So this is the outline for load duration curve, and you have to highlight in exam also. Okay, whenever there is a question, draw the load duration curve. Okay, you have to highlight the outline of this particular load duration curve. Now the area under this load duration curve, whatever the area under load duration curve, it is equal to the area under load curve. That is the most important one. Okay, so whatever the area under load curve, it is equal to the load duration curve. Now what are the use or the application of this load curve and load duration curve? That is important. Now this load curve is used to find out the what is the demand for this particular time. Okay, if there is any generating company is there, generation company is there, he want to find out how much demand is there for when at the 4 p.m. So in that case, you will just see the at the 4 p.m. it will require nearly 40 megawatts of electricity. Okay, that is the demand. So at that particular time, what should be the demand? It will be observed or it will be found out by using load curve. And load duration curve is this is particularly used to select the generator. Means what should be the maximum capacity of the generator it will require whenever we select the generator for their particular power plant. It is the find out by the this load duration curve. And as it indicates, we required a generator which is having maximum, if it's maximum capacity will it should be a 80 megawatts or more. Okay, it should be have the capacity 80 megawatts or more. Generally it is more than the 80 megawatts because we have to keep some factor of safety in that case also. So it will be greater than the 80 megawatts, so we have to select the generator which will provide which will produce the uh, electricity 80 megawatt or higher than the 80 megawatt. Their capacity must not less than 80 megawatt. That is the requirement. So by using load duration curve, it will find out which type of generator it is required. Okay, this is regarding the how to draw the load duration curve. The next, that is we are going to find out the total load factor of the power plant and what is the load factor of the standby equipment. Okay, so that we are going to see here. Now first of all, the total energy generated, that is the just an area under the load curve or load duration curve. So we have to first find out the total energy generated, that is area under the load curve. By using the trigonometry you can find out the area. Okay, and that is the 1140 megawatts hours. Okay, and the average load you can find out also, you can find out the average load, that is the total energy generated divided by total time, that is the 47.5 megawatts. And load factor, you already know the formula for the load factor. It is the average load divided by maximum load, or the average load divided by peak load. So average load will be 47.5 divided by peak load is the 80 megawatt, because this is the peak load, right? This 80 megawatt is the peak load. So we are considering this 80 megawatts as the peak load. So that will be your load factor for this particular power plant. That is 0.594. Okay. The next point we have to find out, that is if the above 60 megawatt is supplied by the standby unit of 20 megawatt capacity, then energy generated. Now what they are saying, the 60 megawatt is the base load power plant. Okay, it is produced by the base load power plant, and the remaining 20 megawatt that will required during the peak load, it is generated by the standby, or we can say the peak load power plant. So in that case we have to find out the load factor for that particular the standby unit. Okay, so in that case, whatever the energy generated by this particular standby, or whatever the energy generated by this particular standby unit, we have to first of all find out. So same formula you have to use, but this formula we have to use for standby unit. Okay, so 60 megawatt will be generated by base load, and 20 megawatt additional requirement of the 20 megawatt will be generated by the peak load power plant. Now this standby unit is only in working whenever the load requirement is greater than 60 megawatt, because this 60 megawatt, up to 60 megawatt load will be taken care by base load, and only remaining above the 60 megawatt will be taken care by the peak load. So only for this from 16 to 22, means nearly for 6 hours, this particular peak load power plant will be in working. Okay, so we have to find out the load factor for this area only. Okay, this particular area. Okay, whenever there is peak load, it is in the working. So for that, we have to first of all find out the average load, and peak load we already know that is 20 megawatt in this particular case, because 60 megawatt will be provided by the base load. So peak load for the peak load power plant will be 20 megawatt. So for which we have to find out the average load. First of all, for the average load we have to first find out the area, that is 20 into 4 plus 10 into 20. So you can see here, this 20, this one will be 20 from here to here. Okay, 20 into 4, for 4 hours we require 20 megawatts, and for remaining 2 hours we require only 10 megawatts extra. Okay, so that will be the area. So area we have to find out, that is 100 megawatt hours. Now it is for 6 hours, right? Because this particular standby unit is only working for 6 hours. So whenever we calculate the average load, we have to divide this total energy by the 6 hours. Okay, and it will give you the average load. So load factor for the standby unit is average load divided by peak load. Peak load we already know, that is the maximum 20 megawatt will be generated by this particular standby unit, and it will be 16.7 divided by 20, and the final load factor for standby unit is 0.835. Okay, so I think you will understand this one. This type of examples will coming in exam. Okay, so prepare for this type of example. You can refer any reference book, mostly refer the Zumkumwar reference book, so you will easily understand. Okay, so similarly there are different numericals are there, where you does not require to draw the load curve or any load duration curve. The direct different data is given. You can directly calculate the different load factor, capacity factor, the availability factor, then plant capacity factor. All those things you can easily calculate by using this particular formula. Okay, so this is another homework. You can use take a screenshot of this particular slide, and do this particular sum in home. Okay, so this is regarding the power plant, or the load duration and load curve and load duration curve. There will be examples based upon load duration curve. What we saw in this particular slide, there will be examples in exams like those only. Okay, you can refer a Dumkunwar book to solve many or just practice out those particular examples. Okay, so for today, this will be the end of this today's lecture. If anybody have any doubt, you can ask now. Look, these examples are very important. Those examples are going to be came in your MSc exam as well as in ESE exam. Okay. So if anybody have any doubt, you can ask now, or you can just WhatsApp me your query. I will explain there. Okay.